Hey guys, so this is page 14, the homework for it, about graphing quadratics in standard form. So a few things to remember. Standard form, remember, looks like this. For a function, it's f of x equals ax squared plus bx plus c. So in standard form for a quadratic, a few things to remember. First, you can't pinpoint the vertex. Okay, with standard form, you have to do one thing first. In order to find the x value of the vertex, x equals negative b all over 2a. Okay, so that is to find the x value. To find the y value, you're gonna have to plug this x value back into the function you were given, okay, into all these x's, and that would give you back your y value of the vertex. Okay, so then we would have our x comma y, and that would be the vertex. All right, so for the homework, let's look at the first one. We have f of x equals x squared plus 6x plus 7. Okay, so the first thing that I notice is that in the front, my a value is a positive 1. So that means when the homework asks positive or negative, that means is the a value positive or negative? Okay, that also means is it concave up, as in it's opening up like this? That would be positive. If it's negative, remember it does a flip or a reflection. So it would open down, or you could say concave down. So I have a positive 1, so that means it is positive. The a value is positive, so it will open up. Okay? All right. If it's going to open up, right, so if I just sketch it, it's going to open up. So my vertex, is that a maximum or a minimum? Well, it's the lowest point, so there's not going to be a max. There is going to be a min, though, and it's going to be at that vertex. So as soon as we know the vertex, it's also going to be the minimum point. Okay, so we need to go and find this vertex. Everything else, domain, range, interval of increase, decrease, everything centers around that vertex. Okay, so to find the x value of the vertex, remember, we got to come out and do x equals negative b over 2a. So I got to figure out, okay, what's b and what's a? This is b, so a positive 6. So negative is in the equation, so then plug in a positive 6. So I got negative 6 over 2 times a. My a value is a positive 1. So negative 6 divided by 2 times 1 is 2. So it looks like negative 6 divided by 2 is negative 3. And that, remember, was my x value of my vertex. So I can come up here and say, okay, negative 3 is my x value. Same thing for the minimum. It's the same as your vertex, like we just discussed. Okay, now to find the y value, I have to take this negative 3 and plug it in everywhere I see an x, okay? So let's do that underneath here, that's fine. So I'm going to plug in everywhere I see an x, I'm going to plug in negative 3. So negative 3 squared plus 6 times negative 3 plus 7. All right, so this equals negative 3 squared. Notice the negative is inside the parentheses, so the negative also gets squared. So negative 3 times negative 3 is a positive 9. 6 times negative 3 is a negative 18. And then I have a plus 7. So if you add and subtract left to right, 9 minus 18 is negative 9, and negative 9 plus 7 is negative 2. Okay, and that was my y value. So I can go and put in my y value to finish off my vertex point. Okay, Now, let's think about axis of symmetry. The axis of symmetry, remember, is that axis that cuts the graph in half, which just so happens it cuts through the vertex. So if I label this, remember it's x equals. So x equals, and what is the x value of the vertex that I cross through? Well, the x value is -3 from my vertex. Okay? Now, domain. Let's talk about domain. Remember, domain is, can I box in this graph from the left side, and can I box it in the right side? Well, this is kind of angled to the left, and this is kind of angled to the right. So your box would have to keep growing bigger and bigger and wider forever. So this is going to be all real numbers for domain. Range. Can I box this in top and bottom? Okay, well, if we look at the bottom, I can box in the bottom because it doesn't go down forever. So I can box it in right here at that bottom, and it cuts through the vertex because that's the lowest point. We said it was our minimum. So remember, when we're doing range, range is our y value. That's only y's, and the x's were our domain. So for range, I have a bottom value. It is at the y value of -2. Remember, we're looking at y's. And then I can't put a lid on it. I can't put anything on the top and box it in because it goes up for forever. So up forever in math is positive infinity, and put parentheses around it. Okay, interval of increase. Where is this graph increasing? Okay, remember you read it left to right. So as I go left to right, I can see that the first half of the graph goes, as I trace it from left to right, it goes down. So that would be an interval of decrease. And then from the vertex all the way to the right, it is an increase. So if I start from the far left, remember these right here, intervals of increase and decrease, are only x values. Only x values. Only x's. Okay? So if I'm doing only x values, I need to ask myself, okay, from where to where am I increasing? And then from where to where am I decreasing? So on the x's, if I label this starts off way off into the negatives, and then it comes all the way right here to my vertex, right? And then from my vertex all the way to positive infinity, I am increasing. So you see we're going to have two intervals here. One is from negative infinity to our vertex, and the other one is from our vertex to positive infinity. So you just got to figure out, well, which one is which? Which one's the increase? Which one's the decrease? So the left side is it is decreasing. So that one would be from negative infinity to our x value of our vertex. So remember, the x value of our vertex was -3. So the decrease would be from negative infinity all the way to our vertex, which had an x value of -3. Okay, then if we start at the vertex at x equals -3 and go all the way to the right for forever, notice our graph is going up. It is increasing. So we would say from an x value of -3 to positive infinity, which means to the far right, our graph is going up. It is increasing. Okay. Last but not least, AROC. That means average rate of change. Remember, this is just a fancy schmancy name for slope. Okay, so our slope is going, we want to figure out the slope between -5, and note there was an x there. I accidentally erased it. From -5 to -3. So that means we need to figure out the point with an x value of -5 and the point with an x value of -3. So I'm going to need to plug this into our function, the original function, to figure out what is the y value that matches -5. Okay, so here I go. I'm going to plug it in down here. So plugging in -5. So I got -5 squared plus 6 times -5 plus 7. Okay, -5, notice the negative is in the parentheses with the square, so it gets squared too. So -5 times -5 is a positive 25. 6 times -5 is -30, and then you just have a positive 7. Okay, subtracting and adding left or right. 25 minus 30 is -5. -5 plus 7 is a positive 2. So that means one of our points is at -5, comma, positive 2. The other one, so we did that one. So the other one is at -3. But if you remember, we've already put -3 in. See, we did it up here because it was actually our vertex. So our vertex came out, the point was -3, -2. So here's the second point, -3, -2. So I just need to do the slope formula on these 2 points to find the average rate of change, aka the slope, between -5 and -3. All right, so I'm going to scroll down a little bit so I can give me some room to do the slope. So remember the slope formula is m equals y2 minus y1 all over x2 minus x1. So let's go ahead and label, let's say this one is x1 and y1, and let's let this one be x2 and y2. So when I plug this in, I got y2 minus y1 all over x2 minus x1. Okay, so now I just need to add these together. So -2 minus a 2 is a -4. And -3 minus a minus, remember, is a positive. So really this is -3 plus a 5. So -3 plus 5 is a positive 2. So -4 divided by 2 is a -2. So our average rate of change between -5 and -3 is -2. All right, so now that we have all the characteristics, let's go ahead and graph this sucker. So I have, let's see, let's do the vertex first. So the vertex, remember, was at -3, -2. So I'm going to go 1, 2, 3, positive 1, 2. Sorry, this graph is really janky. I couldn't get a clear one. Okay, and then you got to ask yourself, is it opening up or down? Well, we already determined it's open up because the A value is positive. So we just need to do the pattern for our graph. So remember the pattern. I'm going to come down here. The pattern is over 1, up 1, over 2, up 4, over 3, up 9 for all quadratics. If they don't have a stretch or a shrink on them, this is the pattern. So here I go. Over 1, up 1. And then same thing, just the other side. Over 1, up 1. And then over 2, up 1, 2, 3, 4. And then back to the vertex, over 2, up 1, 2, 3, 4. And then 3, 9. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. So way up there. And then 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then carefully connect your dots. Don't just do it haphazardly. Oops, that one was a little off. That one probably should have been more like right in here. I can't really see. And then arrows, people. Arrows on the ends. Why do we put arrows? Because it could go on for forever. All right, and that's it.